Hi all, here we will be discussing question number 36 from GATE Chemistry 2020. The correct combination of L1 and L2 Mn H minus NO minus MECH2 minus and CO that will satisfy the 18 electron rule for both metal centers in the following neutral molecule is. Given atomic number of ruthenium is 44. Option A H minus NO minus. Option B MECH2 minus NO minus. C MECH2 minus CO and option D H minus CO. Let us first understand what is 18 electron rule. This rule assumes that the central transition metal atom can accommodate electrons in the ns, np and n-1d valence orbitals, thus giving a maximum of 18 electrons, and such compounds that obey 18 electron rule are typically stable, and hence this rule is quite useful in predicting the structure and reactivity of organometallic compounds. So, in order to find whether a compound obeys 18 electron rule or not, we have to find the total electron count, which can be obtained by adding the total valence electrons on central transition metal and the electrons donated by ligands that surrounding it. The valence electron on any central transition metal atom can be obtained from its electronic configuration. But how to know the number of electrons donated by each ligand? Let us see some examples to understand that. Ammonia. It doesn't have any charge. It is a neutral ligand and it has one lone pair of electrons. One lone pair means 2 electrons. Hence, it can donate 2 electrons and it is a 2 electron donor. The next one is CO. There are totally 4 valence electrons on carbon, among which 2 is bonded to oxygen and hence 2 electron is remaining, which can be donated to any metal. Hence, carbonyl is also a 2 electron donor. Similarly, if we consider any sigma bond, for example, H sigma bonded with another H, hydrogen. Any sigma bond is made of 2 electrons. Hence, sigma bond will also be 2 electron donor. In many cases, the number of electrons donated may vary depending on whether the ligand is at the terminal or at the bridging position. But one thing you can remember is that in case of neutral ligands and sigma bonds, it gives the same number of electrons whether they are at terminal or at bridging position. Next example is H. This is always a 1 electron donor since it has only 1 electron at its valence shell. So, whether this is at bridging or at terminal position, it will always be a 1 electron donor. It can never donate more than that. Whereas, the number of electrons donated by Cl changes depending on whether it is terminal or at bridging position. You know, Cl has a total of 7 valence electron. It needs 8 electron to complete its octet. So, at first, it will try to complete its octet and share only one of its electron to the first metal atom. Now, once the octet is completed, Cl can give its lone pair to the next metal atom attaching to it, thus becoming a total of 3 electron donors. Now that we know how to calculate the total electron count, let us move on to the question given. The number of valence electron on the central transition metal ruthenium is 8. and carbonyl is a 2-electron donor. The next ligand attached to the ruthenium is cyclopentadienyl, which is a 5-electron donor. Ruthenium also has one metal-metal bond, and each ruthenium will get 1 electron from the metal-metal bond, thus getting a total of 8 plus 2 plus 5 plus 1, that equal to 16 electrons. In the question, it is told that the compound follows 18 electron rule. That means each ruthenium needs 18 minus 16, that equal to 2 electron. Thus, we can say both the L1 and L2 are 2 electron donors. Now, our task is to find 2 electron donors from the options given in the question. First one is H minus. We have seen earlier that this is always a 1 electron donor, whatever the condition be. The second one is NO minus. For NO, we know that nitrogen has 1, 2, 3, 4, 5, 6, 7 valence electrons. So it will try to gain 1 electron first in order to complete its octet, thus becoming NO minus. That means it will share 1 electron with the metal atom, and hence it is a 1 electron donor. The next one is MeCH2 minus. Here also carbon has totally 1, 2, 3, 4, 5, 6 valence electrons. It will try to complete its octet, thus sharing 2 of its electron, that means gaining 2 electron from metal and sharing 2 electron to the metal, thus becoming MeCH2 minus, and this is a 2 electron donor. The next option given is carbonyl. We have already seen that carbonyl is a 2 electron donor. So, the correct combination of L1 and L2 among the 4 options given is MeCH2 minus and CO, which are 2 electron donor. So, the correct option is C, MeCH2 minus and CO. For further references, you can visit NPTEL site, classes, and the YouTube link is given here.